Hi, in this section we are going to talk about visualization and summary tools. So this is the number 7 and I will just, let me put it here a bit lower. And then we go to the section number 7, visualization summary. I prepared this one in a different way, so this is not slides, but now we have like this kind of text like this, and I will explain later why. But it's basically because we need a bigger place to show the plots and everything, so that's why we are using this other format. And then in this is a show and tell section as well. So what we are going to do here is that you can follow up in this markdown file here in the website, but also in the scripts that I prepared during the classroom materials. So you can just click download here and click on to get the R project. So this is the R project that we are working on. This is the R project, and for this section we are going to use these packages. The R package Placket Loose, which is the one that we have been using for a while, Digipot 2, Gosset, iGraph, and Leaflet. So remember that to install the package Gosset we need to use the command that I also provide here, which is the install GitHub. The install GitHub, you have to use the install GitHub command to download Gosset in your computer. The others you can just download, like install on CRAN, like this. You do is install packages, and then you put the name of the packages in this vector. So you put the name of the package and then comma, quotation mark, and iGraph, and leaflet. So this is how you install the packages. And plus we are going to use some functions that we developed for the ClimaHub analysis that's done inside the ClimaHub platform. But you need just to take a source of these functions, external functions, for the summaries. So in this first we are going to do two things. One is the beans data, and the other one is with the sweet potato data that we were talking about in the later sections, that I also demonstrate to you how the data was organized and how was the structure of the data our project used. So in this here, we are going to use the beans data that comes out with the Placket Loose package. So this data is already there in Placket Loose, so we just need to use the function called data, and then here we put the name of the data set, and also showing where this data set comes from. So this is, I will just type it again for you to see. So it's data, beans, and then package, Placket Loose. You know that Placket Loose has a capital, so Placket Loose. And then when we do this, it comes with this thing called promise, and then the data is already loaded. So if I use the function called, for example, some summaries now for you to see the data set, is you can use, for example, the command, the function view, for example, view beans, and then we can have like a visualization, like a table-like visualization with how the data is. So here we have the variety names, the tricot varieties, A, B, and C for each of the farmers, and then the best and the worst for the overall preference, and also the preference regarding the local variety. If the local variety was better or worse than the variety A, better and worse the variety B, or better or worse than variety C. We already talked about this. The season, the year, the maximum temperature, the longitude, latitude, and the planting date. So we can also see this with this function called structure, str, which we can see the structure of the file. The function summary also gives to us some summary tools. For example, you can see if we type summary beans season, we can see that this was tested in 5 seasons, and then we can see the number of plots in each season. And also here we can use, for example, this function called unlist. So then what we can do is, for example, we have the 3 columns now with variety A, B, and C, and we can convert the 3 columns as remember now that I said the data frame is a kind of a list in R. So then we can convert the 3 columns, the 3 parts of this data frame, into one single vector. So this is what basically unlist does. So let's do it's unlist, and then parentheses and beans. And remember that we have to put the comma as we saw in the indexing part, because here we were working with the columns. So then I will put the name of the three columns here, and if I run it, it will return to me like a very long vector with the 3 columns unlisted. So I will save it as something called items, so I will call it items. I'll keep this object here, and then with this function called table, we can basically see how many of the items or the varieties were tested in the project. So items, so if I put table items, I can see here that basically they had the same number. Now it's a very balanced the number of varieties that were tested. So between 200, let me do, if I do like sort, so it's between 234 and 270 varieties that were tested at the time that this variety was tested in across the 842 farms. So then we have table, and it's also possible that we can compare the number of varieties and how many times they were tested in each season. So remember we have 5 seasons, so then we can use the same function called table. So then we can create a table where we can see the number of times that the variety was tested in the project by season. And we can do this also by region. For example, if you are working with a different project and you want to see how many times the variety was tested in each region, you can use the same logic here. So what we do is that we use the same function table, and then we put items as the first element, and then we use the function called rep, which is a repetition. So it will repeat the vector. Which vector we are going to repeat? Beans. Season. And then I want to repeat it 3 times because we have 3 columns, so three varieties now, A, B, and C. So 3, and this we're going to return us in the rows the variety names, and in the columns the seasons where this variety was tested. So here we can see that of course it also follows the same idea of the varieties which have a lower number, posterior 16, but we see that here also within the seasons the variety was tested in a almost homogeneous way. So this is another way to make the summaries for your tricot data. And now we are going to go for the visualization part. So and then we one of the functions that we can use, for example, is a function called density. The density function, I think I explain a bit what this means. the density function computes the kernel density estimate of the maximum of the some variable, no, a numeric variable. So in this case, we are going to make the kernel density of the maximum night temperature, which was the variety that the variable that we had registered in the data set. So we put density and beans in max tn, and if we plot this will give to us the values of the density function. So if you want to see it, we just need to put plot density, and with this we can see that the variable is basically like have two modes. Now it's a bimodal distribution. So the first mode is this one here, where we have the peak of temperature around 16 degrees. So most of the density of the data is around 16 degrees Celsius. And the other one is another peak that goes around 19 degrees, so generally, so here, no? So it's a kind of a bimodal distribution in the data. And this is the kernel density of this. And we can also use some other, like if you want to make it like a more professional, no? You can also put like you put a comma after the density, then main, and then we can put a title in the plot, no? So kernel density of night temperature. And then with this we have the plot now. And what? How about I'm skipping this now? If I want to keep this plot, if I want I like this plot and I want to use it in a Word document or something else. So one way to do it is, since this is not with Digipot we have a different way to do it, but this is a plot that comes out of the base R, no? So GR devices, GR devices, which is basically the package that makes this kind of plots in R. So since this comes from this GR devices, we need to do like another way to save this kind of plots. So the first thing is that we use the function called PNG. First of all, we remember that we are looking at the idea of project-based workflow. So then the first thing is that we have to create something, an output to keep this project. No? So here in our dataset, in our project directory, we have the data, we have scripts, and we have a folder called slides, but we don't have any folder called output. So of course you can also create one folder here by hand, but programmatically you can create a folder like this, dir create, and we can also put this let's give it here. So dir create, and then we put the name output. So this is going to be the name of the file, the folder, and then I can also say show warnings. I don't want any warnings, because most of the times these warnings is just saying that the folder already exists or something like that. So then you just create a folder, and then here's the folder. So this was just like a parenthesis showing you how you can create a folder. I can also put it here in the front. So then we have a better workflow. We have already the output created. And then to save it is this. Now we call this function called PNG. And then we choose the file name. So the file name will be output, which will be the directory, and then this, and kernel density max night temperature, and then I have to put the extension, so it should be a PNG file, and then I can choose the size of the plot. No? So let's say that will be with a width of let's say 15 centimeters, and the height will be also 15 centimeters, and the resolution is let's say 300 dpi, and the units is in centimeters. Now the first two units that I used was centimeters, so this is it. And then I will write here the same call for the plot. I will call for the plot here, and then I just need to put dev off, so this will close the device. Now remember I was saying about DR devices, so this will close the device. And then I need to run these 3 lines of code, no, these 3 chunks of code at the same time. So the png plot div off, and then if you look at the folder, the plot is here. So this is the plot that we created and we exported through the output folder. So another visualization tool is the Boxplot, and I think here I have also a comment regarding the Boxplot. So the Boxplot is that you can visualize the quantiles, the quantiles of the data, so to check how is the distribution of it. So we can also visualize this with the function Boxplot, which is just putting Boxplot, the function called Boxplot, and beans and max night temperature, and this is the Boxplot. So then we can see how is the distribution of the data in terms of the quantiles. Now we see that most of the mean value of this is around 18 degrees, and there is a upper level around 21 and the lower level around 13 degrees. So this is how the data is distributed. And sometimes when the data has some outliers, when some points are out of the distribution curve, so we can see these outliers as some dots here, like they go outside these bars here that we see. This is not the case of this data set. And also another way to visualize things in R is we can also visualize, remember this data we have the longitude and latitude, the coordinates. So when we think about what R does, is just we can also take, for example, the summary to see how is the minimum latitude and the maximum latitude, and this where is the median point on the distribution of the points in this experiment. And we can also use the function plot to plot the points. So it's plot and beans and comma c long, which is the long is the x axis and lat is the y. So then we put it, and then we have the points, like the geographic points. But this is not so informative. No, this is just a scatter plot with the points distributed in a xy vector. No, it's xy Cartesian plot. So to get some information out of it, to make, for example, to make a map or something that is actually informs us about the geographic points, we also can use some of the tools that are available in R. So, for example, the package SF. The package leaflet is the one that also provides information for us, like some tools, so we can visualize this with a baseline on a layer, a geographic layer. So for this we use the function that comes from the cleanup workflow, the one that we run here, this R script here. So this function is called plot map, and it runs internally some of the functions of out of the package leaflet. And if you want to see more about leaflet, just go here in this link and you can read more about it, and also take map providers like the layers for the maps. And to do it, we just need to use the function plot map, plot underline map. So plot map, use the function. So plot map, and then I put the name of the data frame, which is beans, and the other column is the XY vectors. No, so the XY vectors is long and lat. And if I just put it here, it will create like a standard map for me showing Nicaragua. No, the experiment comes from Nicaragua, and basically this is the layer that it's by the standard in the function. And we can also take like we have a mini map here showing Nicaragua in a bigger picture, and where the point is now, like where the points are located. So it's basically in central north Nicaragua. And to get a different map provider, you just need to look at here. No, if we look at this here, we can see the providers. So there's many providers here showing which kind of map you can take for the leaflet. No, this is the name of the map. And here I will use this one called OpenStreetMap.mapnik. So if I call the same function and I use the argument map provider with informing the provider that I want, I can have a bit more informative map, for example, showing the administrative regions in Nicaragua. So then I know where the points are located and where the plots were established for the beans variables, the bean varieties. Here we can also visualize the rankings. It's nice to see how connected they are, how the varieties are linked to each other in a single experiment. So to do it, we use the function rank tricot from the package GoSet. So remember that the first argument is the data set, the second one is the variety A, B, and C, the items, and then the input, which is the rankings, the best and the worst. And in this case, we are not going to use the local variety, so it's just the tricot varieties. So we just need to run it, and just to confirm, the class is a class object of class ranks. The dimension is 842 rows and 10 varieties, 10 columns. And if I press head, it shows to me the six first rankings. And with this function called unclass, I can go from the bracket loose rankings to the sparse rankings that we were talking about in the previous section. So I have the name of the varieties, and then all of them with the rankings, and the ones that's missing for this row is filled with a 0. And to visualize the network, we first use this function called adjacency from bracket loose. So I will call it A, and then adjacency, and then R, which is the object that we created here, the rankings. And with this, I have the adjacency matrix, which shows the number of times one variety wins against the others. And if I use this adjacency matrix with the function network from the CleanMob workflow, I can plot the network of the varieties. And with this plot, and then we can see, for example, how connected were the varieties. Even if they don't co-occur in the same project or in the same trial, in the same plot in the farm, since they belong to the same trial, so they are connected to each other. They co-occur in this trial, even though they are not in the same plot, a farm plot. So you can see the name of the varieties here, and the way that they are connected to each other. And also in the GoSet package, we have some functions that are called summarize. And these functions have one of those is this one called the summarize favorite. So here we can see the favorability score of the varieties. So the main input for the favorability score is an object of class rankings. So what we do here is that we call this function, I will call it FAV, and then I call summarize agreement, and then I just need to put R, and it's run. No, it's not summarize agreement, it's summarize favorite. Summarize favorite, and then it returns to me one data frame where the number of lines will be the number of varieties that are tested in this R rankings, no, in the ranking, and then it shows to me the number of times this variety was tested across the entire ranking. How is the proportion of times that the variety was ranked as the best one, and how was the proportion of the time that was ranked as the least one in the ranking, or the worst one, and how many times it wins in proportion of time, and how is the favorability score. The favorability score is the difference between the best and the worst. So in this case, for example, for Intasequia, the favorability score is 16. So in the case of this project, it was the highest one. And we can also plot it. No, we can use this function plot fav, and what it is going to do is that it will create the plot based on the Digipot tools. No, so if I call it plot fav, it will create to me this kind of plot here. And this plot, I can also put some extra arguments. If you want to know more about Digipot, you just need to go on Google, for example, and then you just need to put Digipot 2 tidyverse, and then there's the entire website only talking about Digipot, what Digipot means and how you can do. This is like the most famous package for visualization in R. So you can just there's a lot of things here, and a lot of tutorials for using Digipot. And Digipot has a different behavior in terms of the way that you code the plots, and you basically, because it's a kind of plot, it's a kind of layer, no? So then you can create layers over the code, and these layers are added with the function plus. So in this case we have this plot, and if I want the plot with a different theme, I can just put a theme BW, for example, which is the black and white theme, and it will return to me the plot in a different way. And I can also put, like, if I want to get this without these grids here, I use this thing called pen theme, panel grid element blank, and this returns to me this more cleaner plot. And to save this, there are two ways, and what I'm going to do is that I will save it as something called P. So I will keep it as an object called P. So if I do it like a class P, this will show to me that the class of this object is of class GG and also Digiplot. So this is what I want. So to save an object of Digiplot, I can use the Digiplot function called the GG save, and that has basically the same behavior as the previous one. As I was showing, you put the name of the file name. So let's say output favorability score beans, and then I can also put the read So let's say that it has a width of 15 and a height of let's say of course height of 30, and then the DPI will be 300. And then I save it, and then you can see here the favorability score, it's already saved. It's a bit too long, so let me put it a bit lower. Units, centimeters. So is it still too big, too short, too long? So let's put like 20 centimeters. And this is more reasonable here. So then we have the same plot in the saved in the folder called output. The other function that we have also is dominance. We can see how dominant is the variety compared to the others. It's the same thing. We just need to run this function called dominance, summarize underscore dominance, and we put the ranking here. And we can see a longer data frame where we have a player 1, because this is like thinking about like torments, no? So it's like player 1, player 2. So it's like a pairwise comparison of them. So the player 1 and how many times the player 1 and player 2 had the contest. So in this case, for example, ALS 0532 was compared to BRT 64 times, and in the 64 times that they were compared, ALS win against BR2 42% of the times. So this is like how many times it wins against the player 1 against player 2. And we can also plot it using the same thing as we saw before. And basically it creates for us a matrix with the dominance of this. So we can see that the more dominant variety here is Intasequia, which wins in most than half of the cases. No? 60, 62, 63, 50, 62, 53, and sometimes even 68% of the times against the other varieties here. And we can also change the names. Now you see that here we see player 1 and player 2. And to change the names, we can use the function labs. And the X lab will be a variety 1, and then Y variety 2. And then it's okay, yes, so then it should be Y and X. Okay, so the Y is variety 1 and the X is variety 2. So this is you can change these names. And the other function that comes out from GoSet is this one that called victories. So we can see how many times the item wins against the others against all the others in a bar chart. So we call it the function summarize victories, and it's basically the same thing that here, but the visualization is different. We have a different way to visualize it. So we have the variety here, Intasequia, and then we have the other ones to see how many the proportion of time it wins now against the others. And if you see, Intasequia wins against the others more than 50% of the times. And this one is the ones that lose or wins less. Wins less or lose more. So this is basically what we have to show. What I have to show you in case of visualization for the beans data. And now we are going to look at the sweet potato data. And to work with the sweet potato data, we need first to read it. No, this is not like the beans that is already in R. We have to read it out of in the disk. So remember that we have this data here in the folder called data. So it's the file called sweet potato. We can also check the availability of the data with this function. For example, list files, and then we want to see the list of files in the folder data, and then we can see there are 4 files. In my case, there are 4 files, and one of those is this one, sweet potato CSV. I copy it, and I'm going to use the function called read CSV. So read CSV, the upper comma data sweet potato CSV, and I will call it DT, and then I read. So it's 1,433 observations and 20 variables. And if I check it head sweet potato, I can see that this is the head of the data. No? So we see, for example, the data was there had the ID, the country. This was experiment out of the results of this analysis are reported in this paper by Moyo and partners and Moyo. So this is the paper, now consumer preference testing boiled sweet potato, and then we have this data set here. So if I use head, I can see like we have the country. So the country is Uganda and Ghana. The districts for the country, the gender of the person that evaluated, the community, the varieties, now A, B, and C. In this case, it's called item A, item B, and item C. The best variety overall, the worst overall, the best one for taste, the worst for the taste, the best for the color, and the worst for the color. And some of the descriptions on why this variety was selected for, based on this, why the evaluator preferred this variety. And you can read more about it in the paper. But for the sake of this exercise, what we are going to do is that I'm going to show to you how can you compare the correlation between one trait to the others, to the others that we evaluate in a tricot project. And for this, we were going to use only the Uganda data, because in Ghana the comparison for the taste and the color was not provided, but for Uganda we have the three comparisons. And then what we are going to do is that we have to subset the data. We have to keep only the Ugandans. So to do it, we first do like this. Remember about the lecture on the indexing, no? So we have the DT, which is the data set, and then brackets, and then we want to filter by rows. So I want the rows that the country is equal Uganda, and then I put the comma, and then I keep this other part empty because I want all the columns for the Uganda data. And then if I do this, I already subset it, but I didn't save it, so I will call it DT again. And then I have only the Uganda data, which is 418 observations only for Uganda. And then the traits that we have is the overall. It's in here, no? If you check the names of the columns. So we have one trait which is the overall. We have one which is the taste, and the other one is the color. So what I'm going to do now is we'll create a vector called traits with the trait overall first, and then taste, and then color. and then I have the traits here, no? Overall, taste, and color. And then I want to create something that's called a cell, which is the traits with the comparison, also the worst, the best, and the worst. No, the strings for the best and the worst. So what we do here is that we use this function called the paste 0, and then we want to paste this vector against this vector here. So then I will run this, and if I do it, I have now one vector with the best overall, worst overall, best taste, worst case taste, best color, and worst color. And now I'm going to create the rankings. This is, sorry for this, but this is a bit like a more advanced, because here we are going to apply a loop. And the loop is basically that we are going to run the same process iteratively. No? So we want to run the same process over a vector, and this is to save time, and also to save that allows us to make a better debugging of the code if we need to do. So when we need to update the code and everything, it's much better work with loops, so then we can debug the code, and there's less chances to get issues and make mistakes with the code, instead of just repeating. Because I could, for example, I could create the rankings for the three things, the taste, overall, and the color. I could create these three rankings independently, one by one, but I would prefer to do it by loops because it's safer. So first thing that I do is that I create a empty list called R, and then I'm going to run to write this loop first. So the first thing that I want to run the loop is across the traits. We have the 3 traits. So we use this thing called for, and then E or I, which is the first, the I is going to be the index for the iteration between the elements in the loop. So for each I in the sequence along traits, I want to do this, and then I use curly braces, and for each of these I want to make a rank tricot, where I'm going to use the DT, which is the data frame. I'm going to use the same items because the varieties will not change. What we're going to change is the reply for the trait, and then I'm going to use the trait. So then I'm going to do input will be paste best and worst, paste best and worst for the traits that we are looking for. So the trait that we are looking here is that it will be the iteration, also iteration. So let's say the trait will be traits, and every time that the loop run, it will look for the next I index. So and then traits, and then I use it two brackets Y. So this is how it is going to be, and this loop we're going to run like this. Let's see. There is something wrong here. Let me see. What is the problem? Yes, the problem is that I forgot to add the lower the underscore. So then now we can have this here, best overall, worst overall, and then if I run it, it will not do anything because I didn't save it. So I have to save it by putting R and then Y now I, and then every time that the loop runs, it will save it in the right place. So then I have something called R, and the R is a list with three rankings, a list of three, so 3 rankings. So each rank is the rank for what I was building here. So the first one is the overall, the second one is the taste, and this third one is the color. So with this, I can use this function called the summarize agreement. And the summarize agreement, we will use a baseline, which in this case will be the overall, against the other traits to compare the correlation between them and how they link to each other. So I will write it again. So summarize agreement. So then the first element will be the baseline, which is the overall, which is in the R list, is the first one. And then for the other ones is the compare to, which is going to be R -1, because I don't want the 1 there anymore. And then labels is trait, taste, and color. So then it returns to me it needs to be 2 brackets here, 2 brackets here, and it will return to me a data frame with the candle correlation. How is the proportion of times that the the variety is ranked first for overall and also first for the other traits, and how is the proportion of time that it's ranked last and also ranked last for the other traits. So in this case, we see that the overall candle correlation is 0.7, because this number should be divided by 100. So it's 0.7 or 0.8. So this is the candle correlation, which is quite high. But for the color, the correlation is actually negative. So there is not a connection, like there's no the color do not drives the preference on the variety for for the overall appreciation. So we can see that the taste is the trait that drives the preference. And then we can see that the taste is ranked first also for overall and for the taste in 80% of the times, and is ranked last in 81% of the times. And if we use the function plot, also the plot from this data frame, we can just put plot, and then we can see plot for this correlation, which can see the negative correlation for the color and the positive correlation for the taste, and being first and being last. So this is some of the tools that I have to show for you in terms of a visualization and summaries for the placket loose and the tricot rankings. And the last section will be about talking about how can we fit a placket loose model and a placket loose with covariates.